If you walk through a garden in the spring, you'll likely spot small clumps of white froth clinging to the stems of weeds and flowers. For generations, people referred to these strange foamy blobs as cuckoo spit or snake spit. The traditional assumption was that this foam was exactly what it looked like: saliva or waste left behind by a passing bird, reptile, or mammal. But if you gently wipe those bubbles away, you won't find animal spit. You'll find a tiny, pale green insect known as a spittlebug nymph. The froth creates a specialized microhabitat that counters the nymph's extreme physical vulnerabilities. As a newborn, the spittlebug nymph is incredibly fragile. It hatches with a delicate, soft body that lacks a tough outer shell, meaning direct sunlight will rapidly dry it out and kill it. Its diet makes survival even harder. The nymph feeds exclusively on xylem sap, the raw, watery fluid plants pull up from their roots. Because xylem sap is severely lacking in basic nutrients, the nymph has a massive dietary quota to meet. To extract enough amino acids to grow, the insect has to remain completely stationary and process up to 150 times its own body weight in this watery sap every single day. Staying in one place for days on end is dangerous when your environment is patrolled by birds, ants, and parasitic wasps that actively hunt for soft-bodied prey. Confined to a single stem, devoid of physical armor, and surrounded by predators, the baby spittlebug is the ultimate sitting duck of the garden ecosystem. Despite the name spittlebug, these insects don't produce their protective foam from their mouths. The bubbles actually come from the other secretes the excess liquid as a heavy stream of urine. This waste fluid serves as the liquid base for the bubbles. Water alone won't hold a bubble shape. To solve this, it secretes sticky epidermal fluid packed with fatty acids. This mixes with watery waste to increase surface tension. The nymph then physically pumps its abdomen, sucking air in and forcing it out to blow 80 bubbles a minute. As the froth builds up, the insect reaches back with its hind legs and actively pulls the foamy blanket upward, impacing its entire body. This behavior successfully turns a constant waste stream into an actively manufactured, engineered biofoam. This foam structure immediately solves the nymph's predator problem. Visual hunters like birds simply see an unappetizing glob of white froth, rendering the insect effectively invisible. If ants or wasps try to probe the bubbles, they are met with a bitter, acrid taste created by the fatty acids, quickly repelling them. The foam also acts as a powerful humidifier. It traps moisture tightly against the insect's soft skin, eliminating the risk of fatal desiccation in the dry daytime air. Beyond simple defense, the bubbles function as a highly efficient air conditioner. This chart shows the thermal performance of the foam. While the external temperature line spikes throughout the heat of the day, the internal temperature line remains steady, maintaining a stable 30 degrees Celsius. The bubble structure functions as a comprehensive survival system, providing a stable, defensive home within the unpredictable garden environment. Safely insulated inside this bubble room, the nymph molts through 5 distinct developmental stages, growing larger and more complex over several weeks. As the insect reaches full maturity, it stops producing new bubbles. The foam slowly dries out, eventually collapsing into a thin, powdery residue on the stem. From that dried crust, the transformed adult insect emerges, the winged froghopper. The adult no longer needs a stationary fortress. It now has a hardened shell, wings, and powerful hind legs capable of launching it 100 times its own body length to escape threats. By leveraging a self-made nursery, the fragile sitting duck manages to survive long enough to become one of nature's most elusive mobile jumpers. Despite this impressive biology, discovering a mass of spit and feeding insects on a prized garden plant can cause immediate alarm for a homeowner. Fortunately, even though they constantly drain sap, a normal population of spittlebugs rarely extracts enough nutrients to cause any lasting harm to an established plant. Many gardeners react to the sight of these bubbles by reaching for toxic, pressurized chemicals to eradicate them. If you prefer them gone for cosmetic reasons, a gentle spray of water from a garden hose is all it takes to dislodge the foam and the nymph. Leaving the cuckoo spit alone provides a rare opportunity to observe a sophisticated, self-sustaining nursery thriving in the backyard.